Hello guys, welcome to the world of neural network and deep learning. In this series, we will delve into the most powerful techniques transforming the industries like the computer vision, natural language processing and more. Deep learning is a branch of AI that mimics the human brain's structure to process the data in ways that traditional machine learning models cannot. Over the course in this series, we will explore the key concepts such as feed-forward neural network, conditional random field, and deep learning architecture like the CNN, RNN. By the end, you will have a comprehensive understanding of how deep learning work and how to apply it to real-world problems. So let's get started and unlock the potential of deep learning together. So, at first introduction, neural network and deep learning represent a cutting-edge paradigm in the AI. The subject explored how machines can learn and make predictions or decisions using the structure inspired by the human brain. Deep learning is fundamentally different from traditional machine learning technique in its ability to automatically learn representations from large amounts of data, eliminating the need for mutual feature engineering or manual. The field is vast, with applications ranging from the speech recognition and image processing to the self-driving cars and medical diagnosis. The learning models in deep learning are trained using the backpropagation, which adjusts the weight based on errors make, made during the prediction. However, challenges remain such as overfitting, interpretability, and the data requirements. In this series, we will cover this issue and explore the various framework and algorithms driving the success of deep learning models today. You will gain a strong foundation in both theoretical aspect and the practical implementation of the neural network. So now, feed-forward neural network. A feed-forward neural network is the most basic type of AI neural network. In an feed-forward neural network, the data flows in one direction from the input to the output without any loops. Hence, the term feed-forward. Each node or neuron in a layer is connected to the neurons of the next layer, where output of one layer serves as the input to the next. Activation functions play a crucial role, helping the neural network to learn the complex pattern. The most common activation functions include the sigmoid, ReLU, tanh function, each serving different purposes depending on type of data. So feed-forward neural network are used in a variety of tasks such as classification, regression problem, and models learning is done through the adjusting the weights using the algorithms like the gradient descent, which minimize the error by backpropagating the error from the output back through the network. Understanding the feed-forward neural network is the key to moving on to the more complex architecture in deep learning such as multi-layer neural network. So now, conditional random field. Conditional random field are a class of statistical models used for predicting the sequences or structures, making them ideal for tasks like this speech recognition, part of speech tagging, and image segmentation. Unlike standard models that make prediction independently for each input, CRFs take into account the dependencies between the output variables. The model is trained by minimizing a loss function, which measures the difference between the predicted and the true values. Regularization techniques such as L2 and L1 techniques are used to prevent the overfitting. Backpropagation is used to optimize the model's parameter by adjusting the weights based on gradient of the loss function. Model selection is another critical aspect of training the CRF, where different hyperparameters and model structures are evaluated for optimal performance. By leveraging the dependencies in the data, CRFs provide a more accurate model for tasks where context play a crucial role. Some advanced conditional random fields, linear chain and Markov network. Building on the foundational CRF, we explored the advanced models like the linear chain, Markov network. Linear chain CRF are widely used for sequence prediction, where the output at each time step depend on both the current input and the previous output. This is common in the natural language processing tasks like the name entity recognition. The partition function and the belief propagation are the key component in these models, helping to calculate the probability of a particular sequence or the structure. In the Markov network, The graphical model structure is undirected, capturing the dependencies among the variables in a way that is useful for more complex tasks. Hidden Markov model also fall into this category, providing a powerful tool for sequence prediction. Training this model involves optimizing the parameter to best fit the data, while entropy measures to help to quantify the uncertainty within the model. Okay. So now deep learning. So deep learning refers to use of multiple layers of in neural network to extract the higher level of features and representation of the data. Feed-forward neural network are the foundation of the deep learning, but more sophisticated architecture like the convolution neural network and the recurrent neural network are also widely used. CNN is specifically useful for processing the grid-like data such as images, where they can automatically detect the hierarchical features from the edges to more complex pattern. On the other hand, RNN are designed for sequence data such as time series or text and are capable of maintaining the memory through their feedback loop, making them ideal for tasks like the language modeling and speech recognition. Deep learning also introduced the regularization technique like the dropout, which help to prevent the overfitting by randomly deactivating the neurons during training. The training of deep learning models is computationally intensive process requiring the efficient algorithms and high performance hardware like GPUs to manage the large amount of data. So now the deep learning research. The deep learning research is an ever evolving field with groundbreaking the advancement every year. Object recognition powered by CNN has revolutionized the fields like the autonomous driving and the security. Sparse coding is another concept that emerged in research aiming to represent the data using the fewer resources while maintaining its essential features. In the context of computer vision, the sparse coding helps in representing the images with minimal computational resources. Natural language processing has also seen massive amount of sets or massive improvements thanks to deep learning, particularly with architectures like the transformer which have set the new benchmark in the tasks like the translation, sentimental analysis and question answering. Research in the deep learning also focuses on improving the robustness, efficiency, and interpretability of the model. With each breakthrough, deep learning is finding new applications from the healthcare to robotics, showcasing its transformative power. By staying updated with the latest trend and models in deep learning, you can leverage this powerful technology to solve the complex real world problems. So, thank you for joining me in this overview of neural network and deep learning. We have covered the foundational techniques and architecture that make deep learning so powerful today. With this insight, you can now approach more advanced topics and explore real world application in AI and machine learning. Remember, deep learning is constantly evolving, so keep learning and experimenting with different models and techniques. Stay tuned for more in depth videos where we will dive deeper into each of these topics. I hope this series inspire you to explore the limitless of possibilities of the neural network and deep learning in your future work.